Hello, Mrs. Middleton here with Season 4 of Apes in the Home. Today we'll be diving into the complexity of our dynamic Earth, so buckle up and let's get going on this refresher from your Earth Science days. The first thing we should go over is the fact that our Earth has layers within it. These layers have different consistencies and densities, with the most dense material, like iron and nickel, in the center at the inner core, which is solid, and the outer core, which is liquid. The layer above the outer core is the mantle. The mantle and crust, which is above the mantle, get a bit crazy, the mantle and the crust, which is above the mantle, gets a little bit crazy. So let's look at the next slide to see how they break that down. Okay, there's a lot going on in this image. If this stuff really interests you, take a screenshot of this image and study on your own time. The main thing I want you to get from this is that the mantle is broken into a couple of parts. At the base of the mantle, you have the lower mantle, which is solid. Above the lower mantle, you have the asthenosphere. Write that word down or underline it. The asthenosphere is kind of plasticky. Think almost of silly putty, where it's a solid but it can be bent or move and can flow. The movement of the asthenosphere is what makes the surface move. Floating on top of the asthenosphere is the lithosphere, which includes the crust and the upper mantle. Here's a more simplified version of what's going on. The plate tectonics that we live on are made up of the lithosphere, the gray part here. The lithosphere is floating on top of the asthenosphere, which is moving because of convection, so heat rising and falling. This movement and interaction of the lithosphere plates are going to create and recycle Earth's crust and gives us an unpredictable ride because of that motion. Here's an image of those lithospheric plates and their edges or boundaries. Places where the plates interact are called plate boundaries, and that's what we are going to focus on the rest of this presentation. There are several types of features you can get when you have two plates coming together to form a convergent boundary. The features you get will depend on the type of crust that is on that place of lithosphere. For example, the top left image has a piece of oceanic crust running into continental crust. You have subduction at the oceanic plate because it's denser, and that subduction creates an oceanic trench. The plate begins to move into Earth, which makes it melt, and you end up getting a volcanic arc. The Andes mountain range is created from this type of boundary. So again, oceanic plate is going to subduct because it's denser. That subduction is going to create a trench over here. And as it gets lower, it's going to heat up. It's going to melt. That melting makes that material less dense. It's going to rise, become magma, and erupt. Here's the right side. The image on the right side of this slide has two oceanic plates converging. Again, you will get an oceanic trench. As the denser oceanic crust subducts under the younger plate. Melting work will occur and you will get a volcanic island arc. The Mariana Trench is an example of this type of convergence. The bottom image depicts convergent boundaries. The bottom image is depicting a convergent boundary where you have two continental crusts slamming, slowly of course because rocks move extremely slowly, but these two are going to slam into each other. You won't have subduction in this. I know it looks like subduction. This used to be oceanic plate. You can see that from, here's oceanic plate, same color. You can imagine almost that there's over on the left here, off frame, maybe there's continental crust. It's going to slide forward, and eventually you might get something like this, where the oceanic crust has completely subducted At this point, there's no more subduction going on. Because they're the same density, instead of any subduction happening, you'll have folded mountains occur. The Himalayan mountains are an example of this. Convergent boundaries are where old crust is destroyed. So this crust is destroyed, this older crust is destroyed. The divergent boundary is where two pieces of crust are moving away from each other. You can see from the top image that the plates start ripping apart and create a rift valley. The Red Sea was created this way and is currently moving apart. The bottom image is what the Red Sea may eventually become. It's an image of how the Atlantic Ocean was created and is still moving apart, making the ocean larger. At the bottom image, you will see seafloor spreading, which is exactly what it sounds like, and linear volcanoes called fissure volcanoes. Divergent boundaries are where new crust on Earth is created. And you can see that right here, magma is pushing up and creating new crust in this area. Same with down here. Transform boundaries, where plates are sliding past each other, can result in earthquakes, and that's about it for transform boundaries. You don't get any upward motion, you don't get any subduction, they're just sliding past each other. Earthquake cité. Speaking of earthquakes, all plate boundary movement will have earthquakes. That's because an earthquake occurs when stress overcomes a locked fault, releasing stored energy. So in any of our boundaries, convergent, divergent, or transform, you have rock moving. And when rock is moving, you can have rocks sliding against each other, getting caught, and then releasing stored energy as an earthquake. Through earthquake and volcanic data, scientists can create maps that show the global distribution of plate boundaries. Using the data collected can also help scientists predict where new volcanoes, island arcs, earthquakes, and faults might be. Well, that's all you need to know about plate tectonics for now. Hopefully it was a great refresher for you. But remember, if you're confused, you may always ask your teacher or the internet. Have a great one!